Good morning, everybody. I wanted to go over some of the circle basics. This is from yesterday and today's assignment. Make sure that you are paying attention to the Google Classroom as far as there has been 2 assignments for yesterday and there are 2 assignments that are due for today. The notes for both these sections are in the section from 44 to 49. We will not cover all of 44 through 49 today, because we will begin the rest of it next week as we talk about the actual segments and circles. So most of this circle basic stuff, the beginning, is pretty straightforward. So here we have a circle. We always label it by our center, so circle A in this case. Remember, radius go from the center to the outside, so we have quite a few radii here, AE, AF, and AB. Diameter, remember diameter must go from side to side and it has to go through the center. Chords, so a chord is a segment that goes from side to side but does not have to go through the center, but it can. So chords, we have CD and EB. Okay. Remember, my diameter equals 2 times my radius. Okay, because there's radius. Together, those 2 radii make my diameter. Area formula, pi r squared. Make sure you're paying attention in the CK12s. Sometimes they want you to use pi. Sometimes they want you to use 3.14. Sometimes they want you to use 22/7. Remember, you can use all of these calculations in Desmos. Desmos does calculations for you just as well as your calculator does. And then circumference, we have 2 formulas. We can either use 2 pi r or pi d. I tend to use 2 pi r just because that's what I'm more familiar with and more comfortable with, but either works. Okay. Tangents. Tangents are the segments that are tangent to the circle. The segments are congruent. They are perpendicular at a radius. So here is one tangent. Here is another tangent. These tangents come through and they only touch the circle one time. If they touch the circle more than one time, they are not tangent. They're what we'll call secants, and we'll talk about those later. But here's my tangent. It touches the circle one time, and it will always be perpendicular. Remember, that means it creates a right angle with the circle, with a radius. Okay, so my angles. So we have central angles. Central angles sounds just like it means. Central means in the middle, the center angles. Okay, so here we notice that we have this angle of 70 degrees. This 70-degree angle, the piece of the circle that it creates on the outside, the pie crust, is going to be the same degree as the angle that was created. Okay, so notice that the central angle and the arc it created are the same. So think about this as the piece of pie you cut. Okay, so here I sliced off a pie at 70 degrees. The degrees of crust is also 70 degrees. Here, let me use a different. Here, I cut off a 100-degree piece of pie, which means I have 100 degrees of crust. Arc length. So each of these pieces, when you take the circumference and break it up into pieces, these are arc lengths. To find out my arc length, we're going to use this formula right here. Okay. The degree measure of the arc over 360 times 2 pi r. You should recognize 2 pi r as my circumference formula. So if I wanted to find the length of just this arc right here, we would type in 100 over 360 times 2 pi and whatever my radius was in this case. Okay? All right. Inscribed angles. So inscribed angles and inscribed quadrilaterals, which is what you're doing today. So an inscribed angle means that the vertex of the angle is on the circle. So notice it's right there on the circle. When we do that, the angle is going to be half of the arc it creates. So if this angle is 40, the arc it creates, it has to be 80. If we draw another one, that wasn't a very good circle, but that's okay. If, say, my arc is 100, this angle has to be half of this. So what is half of 100? 50. So this would be 50 degrees. Make sure I put my degrees. Okay. All right, inscribed quadrilaterals. So remember, quadrilaterals means four-sided shapes. So if, or any shape really for right now, if we're looking at a triangle inside, if it is a right triangle with the hypotenuse as the diameter, this is an example of it. This is a formula that I don't always necessarily remember. Okay, but if you think about it, this is 90 degrees, so the arc it creates has to be twice that. So twice of 90 is 180. Remember, and if you don't, make sure you put a note on it. There are 360 degrees in a triangle, or in a circle. Make sure you know that. Okay. And last but not least, the quadrilaterals. Opposite angles of an inscribed quadrilateral are supplementary. Remember, supplementary means that they total up to 180. So opposite angles, here and here, total 180. Here and here will have to total 180. Okay? All right. After you finish this, go ahead and start working on your 2CK12s. And then make sure you watch the announcement that is posted in the stream about what you should have completed and what is going to happen next week.